Alright, this video we're going to look at law of sines, okay, which is a way to solve triangles when they are not right triangles. Okay, so we used the trig function, sine, cosine, tangent to do right triangles last time, but now we're going to look at triangles that are not right triangles and what can we do to solve them. So here is the law of sines, okay? The measure of a side over the sine of that angle is equal, that ratio is equal for any of the three angles in a triangle. So here's what it looks like, okay? You give a triangle and here they gave us angle A, angle C, and side C. So I'm going to fill that in over here. So angle A is 46, angle C is 63, and then side C is 56, okay? Angle B is the easiest to find because all the angles in a triangle have to add up to 180. So if I subtract the other two angles that I am given, I will get that missing angle. So angle B would have to be 71 degrees, so I can fill that in, okay? And then to find our missing sides, we're going to use the law of sines. All right, so I have both angle and side for C, so I'm going to use that. So the sine, all right, of 63, because that's angle C, over side C, which is 56. All right, and then we're going to just pick one to do our missing one. So we'll do A first. All right, so the sine of angle A is 46, okay, over whatever side A is. We don't know. Okay, we have two fractions equal to each other, so we're going to cross multiply. So sine of 63 times A is equal to sine of 46 times 56. Okay, and then of course to solve this, we would divide by sine of 63. Okay, and you're going to do that part in your calculator. So when we do all of that math, I end up here with, I'm going to round to the nearest tenth, so 45.2. So this length of side A is 45.2. A couple things important to remember. Do not round here until we get to the final answer. So in my calculator, I typed in sine of 46. I got an answer. I multiplied that by 56, got an answer. And then I divided by sine of 63, and I only rounded at the end. So we're not going to round in between. Okay, so then we're going to repeat that process for side B. All right, and because I now have side A and angle A, I could use A or I could use C again. I'm just going to use C again, especially because neither of these are rounded numbers, so it just makes it easier. So sine of 71 this time divided by side B, and then same thing, cross multiply, and then divide so that you can solve for B. Alright, so that sets me up for B is equal to, and I do all that math, and I wind up with 59.4. Alright, so now I have all three sides, all three angles, and I'm good to go. Then we have to look at what's called the ambiguous case, which is a special situation. So when the three pieces of the triangle that you are given form side-side angle, if you remember from geometry, this is backwards, this would be an inappropriate word, and it means that we can't use it to prove triangles are congruent. Okay, it also kind of messes up with our law of sines. So here's what happens. I have angle A is 43, side A is 81, and then side B is 62. Okay, so when we end up with this situation, that is a side-side angle. And what that means is it's possible that with these three measurements, there could be only one triangle. It's also possible that I could form two different triangles with these three measurements, and it's possible that it's not even possible to make a triangle. So there could be 0 triangles, 1 triangle, or 2 triangles. So let's look at what we would have to do to solve this. The first piece that I can find is angle B. So I'm going to set up my law of sines so that I can find angle B. Alright, so sine of 43 over 81 equals sine of angle B over 62. And I'm going to cross multiply. Cross multiply and divide to get B by itself, and I wind up with I have 0.522, and then it keeps going. Now, I wrote this down just for the purposes of being able to talk about it, but you are not going to round at this point. So what we have is that this number is equal to the sine of angle B, but I need to know what the actual measurement of angle B is. So this is where we have to do the inverse sine. So I'm going to do the inverse sine, and instead of trying to type that number in, I'm going to tell the calculator use that answer, because even this is rounded, and I don't want it to be rounded. So if I hit Shift and then the negative button, see how it says A and S? That means answer. So your calculator is going to use that previous answer. So the inverse sine of this answer, all right, and that means that angle B is 31.5 degrees. Okay, so angle B is 31.5 degrees. Now, here's what we have to check. When your calculator does inverse sine, it is giving you the angle in the first quadrant that has a sine of 0.5222. But you remember when we looked at the unit circle, there's an angle here that has a certain sine, but there's also an angle over here that has the exact same sine. So what we have to check is, if I use this other angle, could I still make a second triangle? Alright, so whatever this angle is, alright, I have to check by doing 180 minus it. So 180 minus 31.5, and that gives me 148.5. So B could be 31.5, or B could also be 148.5. But if I made a second triangle and B was 148.5, I already know that angle A is 43. It's not going to change. If I add those together, okay, I end up with 191.5. That's more than 180, so I can't make a second triangle there. Okay, so this is an ambiguous case where there's only one triangle. And to finish this out, we could find angle C by doing 180 minus those, all right, and then use law of sines to find side C. Okay, here's another side-side angle example, okay, and I set up my law of sines, all right, and when I do this math and put the inverse sine in the calculator, I get an error. All right, what that means is there is no triangle here. It's impossible to make a triangle with this angle and those two sides. Okay, and then the third thing that can happen with a side-side angle triangle is you can end up with two triangles. All right, and we will go through an example of that in class.